6.2 Trigonometry of right triangles. So trigonometric ratios are ratios of the sides of right triangles. We have sine, which is the opposite from the angle theta over hypotenuse. Cosine of angle theta is the adjacent leg over the hypotenuse. Tangent of theta is the opposite leg over the adjacent leg. The cosine of theta is the hypotenuse over the opposite leg. The secant of theta is hypotenuse over adjacent. And cotangent of theta is adjacent over opposite. A lot of you know the trick, SOHCAHTOA. This one's for sine, S-O-H, CA, C-A-H, TOA, T-O-A. And then the reciprocal is just flipped. So we have our triangle. This is a right triangle notated by the corner. Here's our angle theta. This leg would be the adjacent. This one would be opposite. And then we know this is the hypotenuse. So this angle theta is what sine, cosine, and tangent are based off of. We know for any two right triangles with an angle theta, they are similar. Therefore, the ratios are the same regardless of the size of the triangle. They depend only on the angle theta and being a right triangle. So here we have two triangles. This one is a right triangle. Here's theta. It's a 3, 4, 5 triangle. Over here, we also have a right triangle with angle theta with a 30, 40, 50 triangle. So if we wanted to find the sine of theta, remember sine is opposite over hypotenuse. Here's theta, opposite it is 3. Hypotenuse is 5. 3/5. If we go to the bigger triangle, sine of theta, we are still on opposite over hypotenuse. Here's theta, go opposite 30 over your hypotenuse of 50, reduces down to 3/5. Same sine value for theta. Cosine is adjacent over hypotenuse. Adjacent would be the leg that the angle is connected to, so 4 over hypotenuse 5. To the bigger triangle, here's angle theta. The leg it's connected to is 40 over hypotenuse 50, reduces down to 4/5 as well. Here we have a right triangle with angle theta. We're going to find the 6 trigonometric ratios of the angle theta. So sine, it's opposite over hypotenuse. Opposite is 2, hypotenuse is 3. We're going to go ahead and do the cosine because it's the reciprocal, h over opposite. So it just flips to be 3/2. On to the cosine, which is adjacent over hypotenuse. Adjacent is √5. Hypotenuse is 3. Now let's do the secant because it's the opposite. So hypotenuse over adjacent, 3 over root 5, and let's rationalize the denominator. So you get 3 root 5 over 5. Next we got the tangent. Tangent is opposite over adjacent. So opposite is 2, adjacent is root 5. Rationalize the denominator. You get 2 root 5 over 5. And the last one, the cotangent. It's going to be the adjacent over the opposite. So root 5 over 2. Alright, so if we have the cosine of alpha, this is a lowercase alpha sign, and it equals 3/4. We want to sketch a right triangle with an acute angle of alpha and find the other 5 trigonometric ratios of alpha. So we sketch a right triangle, indicate that it's a right triangle with the square in the corner. Here is our measure alpha. So we have the cosine of alpha equaling 3 over 4. And we know cosine is adjacent over hypotenuse. So we fill it in. Adjacent, that's the leg connecting with the angle, so this is 3. That makes this one 4. So that means we have to find our other leg. We'll say it's b, and we know a formula to find the side lengths. A squared plus b squared equals c squared, the Pythagorean theorem. So you go 3 squared plus b squared equals 4 squared. 9 plus b squared equals 16. Solve for b. B turns out to be root 7. So, we have the cosine. We can find the secant by just taking the inverse, the reciprocal. So secant of alpha is 4/3. Let's go to sine of alpha, opposite over hypotenuse. So root 7 over 4. Cosecant of alpha is the reciprocal of the sine. So 4 over root 7. Rationalize the denominator. You get 4 root 7 over 7. And tangent of alpha, opposite over adjacent. So root 7 over 3. And the last one is the cotangent of alpha, 3 over root 7. Rationalize the denominator, 3 root 7 over 7.